Hello, welcome to the wonderful world of random sequencing. This is my channel here on YouTube. I also have a channel called Sequencing Random Numbers, and that's my email address there. We're going to get into the concept of virtual numbers. This is something you have to know to understand the sequencing when it comes to randomness. Virtual numbers, metamorphic numbers, binary numbers. Here's a binary number. Got to understand bridge numbers. These help to link sequences, the 11, 13, and 14. And binary to decimal numbers. This is a binary to decimal number. Algorithms. All numbers have an algorithm, and big numbers too. They have an algorithm. And algorithms are also linked to the right-hand side, like this right here. And sometimes they're big numbers, like here's 59. Anyway, so this is the concept of the algorithms, and then bridge numbers. I already said these are bridge numbers right here. So we're going to be talking about this particular sequence right here, Lotto sequence. It is the 3, 11, 21, 23, 45, and 14. Now, all these sequences are relational to each other. This 3, I'll explain over here. The 3 is related to the 11 because the binary 1 1 in binary digits is equal to 3. Now, as you can see over here, it landed on 3, and then it translated itself as a binary digit right there. You see. And I will explain this sequence, the 1121 sequence. Now, the 1121 sequence is equal to 11. The 21 carries the statement 2 1s. 2 1s. What is 2 1s? 1, 1, 1. That's 2 1s. So after it's sequenced to this digit, it went into the 11 is equal to 21 right here. See, 21. And then it's sequenced to 23. Now, how that happened is, let me explain 23. Now the 23 carries the statement 2 3s. What is 2 3s? 3 3. So over here, as you can see right here, notice that it has the 3. And I already said that the 11 is equal to 3, right? So what it has here is actually 3 right there, and the binary digit 3. So what does it create? 3 3. Now there's your 3 3, and 3 3 is equal to 2 3s. Let's see, 3 3. And so if that is the case, then it sequences to 23. See that? So all these numbers here are relational to each other. And then it gets into the 45. Now how the 45 got sequenced is in relationship to these numbers here. In other words, these numbers here on calendar dates and ticket numbers, they have a relation with the sequences over here. Now, even though these have been planned out way in the past, but there is synchronicity between these numbers and the ticket numbers and the sequences that are taking place on a particular day. Now, as you can see right here, we got 90, right? Now, if you divide 90 in half, you get 45, 45. So these sequences here have a relationship with these numbers right here. As you can see, like here's the 13, right? It sequences to a 3 there, right? And so you could even assume there's going to be a 1 there, and you would be right there. Let me explain how these numbers get kind of transferred into different areas. Like for instance, you see this number right here? Let me explain what that is. Over here, this is the 2111, right? 2111. When this is what you call binary to decimal number, and this adds up to 14. Now, the 111 in binary notation is 7. That's equal to 7. You see 111 right there? That's equal to 7. And so when it links to a 2, it creates 27. Now the 27 carries the statement 2 7s, which is 7 7, and 7 plus 7 is equal to 14. So this number right here is equal to this 14. I'm sorry, right? This number right here is equal to this 14. So you can see how all these numbers are interrelated to each other through the sequences here. Here's your 13, right? And if you look over here, notice how you have the 12, 11, and as over here, notice how I did create 11, 21, and then this 21 got reversed into this sequence, which still equals 27. In other words, if you were to add the digits again, 1, 1, 1, that's 7 linked to 2. It's just like this sequence right here. So this is something that happens with this particular sequences, that they get inverted like this, you see. So here's the 21 right here. Now it reverses its sequence to a 12, but it still creates the same 27. So this is 27 and this is 27. I want to go back to the 45. Interesting, because I like to go back and kind of history here. Note so what I do is I usually look for 45. Now if you go over here, notice how you do have a 45 right here. This is an entirely different sequence. So the distance between this this 45 and this 45 is 154. So notice how that does have, you know, it's kind of a reverse number of the 45, you see. And if you go over here to the ticket numbers, and we're looking at 45, right? 45 right here. So this is the ticket number. If you were to see the distance between this ticket number and the 45, right here, right? The distance between here and to this spot right here is 45. You see? And so it's interesting how these numbers kind of link together. So here's a 45. I'll show you right here. Here's a 45 right here. See that? If I was to count upward to this spot right here, to this spot right here, to where we at right here, that's 45. At this spot right here is 45. So there's a interesting relationship in these sequences here. So this is pretty much it. I hope you enjoyed the sequence, and I'll be doing a lot more analysis on random sequences. And I'm looking for people who might have a history of about 10 years of SuperLotto Plus, the Mega Millions, and the Powerball. And this is my email address. So if you happen to know a website that has a link with all those sequences for about 10 years, I'd like to do some analysis on those lotto numbers and then post them up on YouTube. So I hope you enjoyed it, and we'll catch you on the next wonderful world of random sequencing.